we discuss vapor pressure of liquid solutions. Clear? Vapor pressure of liquid solutions. Vapor pressure of volatile liquids. Vapor pressure of solutions of volatile liquids. So, in this part, we discuss vapor pressure of how the vapor pressure of liquid solution varies. Okay. So, the relationship connecting the mole fraction and vapor pressure of liquid solution is explained by the scientist Raoult. Raoult is a French chemist and the law is known as Raoult's law. According to this law, the statement of the law is Raoult's law states that for a solution of two volatile liquids, the vapor pressure of each component is directly proportional to its mole fraction. See, P1 be the vapor pressure of component 1, P2 be the vapor pressure of component 2, X1 be the mole fraction of component 1, X2 be the mole fraction of component 2. According to Raoult's law, the partial pressure of each component is directly proportional to its mole fraction. P1 first component, partial pressure of first component. According to Raoult's law, P1 is proportional to X1, P2 is proportional to X2. Therefore, P1 is equal to P01 into X1. Here P01 represents or denotes the vapor pressure of the pure component. For example, P1 be the partial pressure of solvent, P01 be the partial pressure of pure solvent. Here P2 partial pressure of the second component, X2 mole fraction of the second component. Therefore, according to Raoult's law, P2 is proportional to X2. P2 is equal to P02 into X2. P02, that is a proportionality constant. That is nothing but the partial pressure of pure component 2. This is P01 partial pressure of pure component 1. P02 partial pressure of pure component 2. Clear? Then from Dalton's law of partial pressure, as you know, total pressure is the sum of the partial pressures of all the components present in the solution. Therefore, P total is equal to, Pt means P total. P total is equal to P1 plus P2 from Dalton's law. Therefore, P total is equal to P01 into X1 plus P02 into X2. Here P1, P01 into X1, P2, P02 into X2. Substitute the values of P1 and P2 in this equation. Therefore, after rearranging the equation, we get one equation, that is final equation. P total is equal to P01 plus X2 into P02 minus P01. Here we know that the total mole fraction of all the components in the solution is equal to 1. Here in this chapter we discuss about binary solutions. Therefore, X1 be the mole fraction of solvent, X2 be the mole fraction of solute. Therefore, X1 plus X2, total mole fraction of all the components in the solution, that is equal to 1. Therefore, instead of this X1, we can substitute 1 minus X2 so that the equation completely in terms of X2. So, P total is equal to P01 plus X2 into P02 minus P01. So, from this final equation P total, we derived one equation. From this equation, we can see that, or we can make some conclusions, that is P total pressure of the solution varies linearly with mole fraction of any one of the component. This is a linear equation, or this equation is in the form of linear equation. Therefore, y is equal to mx plus c. So, you already studied in mathematics. Therefore, y is equal to mx plus c form this equation. Therefore, this is a linear equation. So, here P total pressure of the solution varies linearly with mole fraction of any one of the component. First conclusion. Second conclusion is depending on the value of P01 and P02. That is vapor pressure of pure components. Pure components means solvent and solute. total pressure over the solution varies with respect to mole fraction of any one of the components. So we can make this conclusions on the basis of the final equation. P total is equal to P01 plus X2 into P02 minus P01. First conclusion is P total pressure over the solution varies linearly with mole fraction of any one of the component, because this equation is in the form of a linear equation. Y is equal to mx plus c. Therefore, P total varies linearly with mole fraction of any one of the component x2. Here the equation is in terms of x2. And then next is depending on the value of P01 and P02. P01 partial pressure of pure solvent, P02 partial pressure of pure solute. Therefore, P total depending on the value of P01 and P02, P total varies linearly with mole fraction of any one of the component. Here the equation is in terms of x2. That's about Raoult's law. Also, the solutions which obey this law are known as ideal solutions, and some of the solutions, most of the solutions do not obey this law, and that solutions are known as non-ideal solutions. So, this is Raoult's law. He's a French chemist, and he explained, or he was the first scientist who gave an explanation in the case of liquid-liquid solutions. Here, P1 is proportional to X1, P1 partial pressure of first component, X1 mole fraction of first component, P2 partial pressure of second component, X2 mole fraction of second component. And then here we can write one proportionality constant, P01, P02. P01 is nothing but the partial pressure of pure solvent, P02 partial pressure of pure solute. And then rearranging the equation, the final equation P total is equal to P01 plus X2 into P02 minus P01. Then next we have to discuss why this Raoult's law becomes a special case of Henry's law. Raoult's law, we already studied the definition of Raoult's law, that is P1 is equal to P01 into X1, P2 is equal to P02 into X2. P01 and P02 are proportionality constant. From Henry's law, P is equal to Kh into X. Therefore, P pressure and Kh is Henry's law constant, X is mole fraction. Therefore, here Henry's law is applicable for gas in liquid solution. Raoult's law is applicable for liquid-liquid solutions, vapor pressure of liquid-liquid solutions. Therefore, Raoult's law has wide range of application because it explains liquid-liquid solution, vapor pressure of liquid-liquid solutions. But Henry's law, that is applicable for gas and liquid solutions. So here the difference is only in the case of proportionality constant. They are derived in the same way, but the difference is only in